Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is part 2 of the previous problem. And if you recall, we had a body free falling down and covering 100 meters before hitting the ground. Free falling down with zero initial speed. What we know, the moment they say free fall, we know that there is acceleration. This acceleration is constant and this acceleration is g, and this g is a constant, it's 9.8 meters per second squared. It's just experimental fact that if we drop the body, no matter what it is, no matter what mass it is, if there is no resistance from the air, it's like it's a rock, a ball, or if this is a feather with no air in the tube where all air is pumped out, we know that the acceleration will be 9.8 meters per square per second square. And this time they tell us that this distance is L, and they are interested in what happens in the last moment. What distance d2 would be covered if t2 is known, 1 second, last 1 second, and alternatively, what would be the time to cover one last meter. So we know distance, find the last time. We know last time, find the last distance. It's very similar on the surface how it is in the beginning when it is the first second or the first meter which we covered here. If this is the first second, we found the distance in the first second. If this is the first meter, we found with d1 known, we found that it's only 0.45 seconds. Right? So, how to approach this problem? The first thing that we would like to know is, of course, because it's a little bit different, because in the beginning here the speed was 0, and here we have gained some speed, and quite a bit of speed. And by the way, we will find out pretty soon how much speed we gain here or how much speed we will gain here. So, the first thing naturally that we want, if we know L, and what comes to mind? Pause. Correct. The formula for the distance, and this distance includes the total time t. And this formula is, pause, correct. This formula is L, distance, initial speed, 0, multiplied by this t, the times that requires to come from here to here, plus acceleration, which is g, divided over 2, this time t squared. And we know, of course, L capital equal gt capital squared. So this is the first thing we want to write, and we immediately can find t from here. Maybe your teacher requires you to memorize this. I don't know what's good it is. Memorization is never good because too many formulas to remember which one applies where. But to derive this formula from this simple fact that this distance L and this time t, and then it's related like this, like this, like this, it's very simple, and we obtain t equals square root of 2L over g. And we can even put here the numbers. We can put here 2 multiplied by 100 divided by g, and I write 10. You with your calculator can put 9.8, and maybe your teacher requires 9.8, and it's precise, but I am a poor guy without a calculator. I put 10, so it would be easier for me, and this it would become square root 110 is 1 of 20. And then again, what is the square root of 20? Square root of 25 is 5. Square root of 16 is 4. That's somewhere in the middle, so I can put 4.5. And let me write it here. and I put T capital equal square root of 2L capital over G, and it would be roughly 4.5 seconds. And that's all I know about this situation. Let's say that we know this distance d2 last meter, and we want to find this time. So we can say that distance that is covered in time t is L, and distance that is covered t minus t2, this distance is L minus d2, right? T, let me rewrite this formula again, square root 2L over G, right? And then we can say that T minus T2, it would be the same formula, only instead of distance L, it would be distance L minus D2. The formula from here to here, this is L minus D2, and the time would be T minus T2, and this applies here. This applies to the whole distance, and this applies to this little section. And this D2 and T2 applies to this section. So I finish this with G. And of course, if I subtract from here, I will immediately receive that T2 equals, I subtract this and this, so T will be gone, T2 will change the sign, so that's the only thing that would be left here, and here would be 2L over G minus square root of 2L minus D2 and divided over G. And again, you can put here your numbers with your calculator and receive the result. But let me show you some little trick how I can do it without using calculator. So I can factor out T over G, and here I will have the bracket square root of L minus square root of L minus D2, right? Because I factor out this and what left inside the bracket. And now I do the trick. And the trick I do is pretty straightforward. All I have to know is the formula A minus B, and I see here I minus B, and if I multiply by A plus B, it would be simple A squared minus B squared. And why I want to do it? Because if I multiply, I will have A squared minus B squared, my square root will be gone. So what I do here, I just write square root of 2 over G, and then I write this bracket, square root of L minus square root of L minus D2, and multiply square root of L plus and here would be this bracket. So I multiply the top and the bottom by the same bracket. And I immediately have here, let me wipe it out because this will be no needed. And this would be immediately become 2 over G, and this would be square root of this would be L minus B squared, this square root would be L minus D2, and this would be multiplication this on this, A minus B on A plus B, it would be A squared minus B squared. And on the bottom I simply write this. Of course it's like a little bit of not true, but if L is equal, let's say 100 meters and D2 equals 1 meter, it doesn't really matter. sorry, and this should be of course the same, it should be minus, because this bracket is the same like this bracket. So it's approximately the same, and then I do 2g, this and this gone, it would be d2, and this would be 2 square L, and then I put this inside, and I receive g2 divided square 2gl. And this would be my time. And let's put me this formula here for this case, 3, and this d2 equals 1 meter, known, and I immediately will receive t2 equals, and let's separate this big case here for the full distance, and thus t2 equals g2 over square root of 2lg. And we can plug the numbers, and we can plug 1 meter, and we can plug 2 by 10 would be 20, and this would be 100, and square root of 100, let me continue because we don't need this, it would be 1 over square root of 20, 1 over square root of 100, square root of 20 again, 1 over 4.5, roughly. And this would be 1/10 because square root of 100 is 10, and it would be 0.025 or 23, I don't know. So basically, very fast, 0.025 seconds of a second that is required to cover the last meter. You can compare it to cover the first meter, and this is 20 times slower. And so the last thing that they want us to do is to find d2. d2 if t2 is known, right? If t2 is known, they want us to find d2. And this is very simple. We have d2 equals L, this distance, minus this distance. But this distance, L capital, is gt squared over 2. This formula. This is the full, again, gt2 squared is the time that requires to cover this distance. Minus the time that requires, this is t minus t2 squared over 2. So it's subtraction of two distances, this distance minus this distance. To cover this distance we need gt squared. And to cover this distance, if t2 is known and it's 1, we need this time. And if we need this time, the distance is this. Exactly the same formula, only different time. And of course we can write that d2 equals gt squared, common denominator, minus gt squared minus 2t t2 plus t2 squared, and all I'm using here is this formula, a minus b squared. It's a squared minus 2ab plus b squared. And this d2 equals 2. And then I put here gt squared minus this gt squared. So they will be gone. Right? Minus over minus would be plus. Plus 2t and g and t2 and minus gt2 squared. Those two are gone. gt2 I can factor out, would be 2g t2 I am factoring out, and I have 2t squared minus t2. And I don't want, I'm too lazy to put the numbers and calculate. You can do it with the calculator. And you should receive something like 40 meters. And I will put this here. I will put number 4, t2 equal 1 second. And d2, I will not use the formula, it's not important for me right now. It would be 40 meters. Roughly. And basically, this concludes part of this problem. First part was first meter, and first second. This part covers last meter and last second, and we received some numbers, and I will discuss those numbers and physics of what is going on in part 3 of this problem. In the next problem, and not to miss it, subscribe, bell, like, question, comment, and put your own problem. I will gladly solve it. Thank you.